Hiya, this is Chibogo and Williams Brown talking about quality of linked open data. Yeah, our highlights is going to be on definition of quality of data, measurement attributes of data quality, definition of linked open data, quality of linked open data, dimensions for measuring the quality of linked open data, some problems associated with quality of linked open data, relationship between a relational database system and linked open data, benefits of qualitative linked open data, some literature reviews, summary and future developments that can be given on this presentation, and references that we had. Data is defined with respect to quality as the fitness of a data to be used or reused. So we are talking about data quality, we are talking about the potential for the use of data or data sets or metadata, which is data of data. We are talking about data that can be ordered or unordered, how they can be used or be effective to be used. Then the ability to be accomplished, to use them to accomplish a given task or domain or application or a field or in a field. Some attributes for data quality, a normal data quality, not just a linked open data, but we're just talking about attributes of a normal data found in a data set. We are talking about accuracy. Data in found that data set should be accurate, precise, focused on one information, legitimate, valid, has a licensing to be used, is reliable and consistent. Such data is timely and relevant, is complete and comprehensive, is available and accessible as at when due and when needed. It's granular. It still retains its main content even though it passes different protocols or different platforms. Linked open data has to do with the set of best practices for publishing and connecting structured data on the web. It permits free access, retrieval, modifying, sharing, and exchange of data or information by users or applications or machines. Data is structured in an interoperable and usable manner. It was introduced by Tim Berners-Lee in 2006, who used URI, Uniform Resource Identifiers, for names to represent real-world objects and things. Also used Hypertext Transfer Protocol of URI so that those names can be dereferenced. This platform or system also provides useful information by using semantic web standard rules such as RDF, Resource Description Framework, and SPARQL upon the referencing of those URIs that have been provided as names of real-world objects, and also includes external differentiable URI to discover more things and to link to more data. Quality of linked open data has to do with the quality of data set found in linked open data. We are talking about the process that evaluates them to check whether they are actually fit to be used by a human being or a machine. So we have some dimensions that are used to assess and check that the data set found in linked open data are of good quality. The dimensions for checking the quality of data set found in linked open data are four. We have accessibility dimensions, intrinsic dimensions, contextual dimension, representational dimension based on the academic literature, reviews, and such that we could lay our hands for this presentation. Accessibility dimensions is subcategorized into availability, licensing, interlinking, security, and performance. Under availability, first we check accessibility of the SPARQL endpoint and server, whether the server responds to a SPARQL query. Accessibility of RDF dumps, whether there is RDF dump provided in such dataset or whether it can be downloaded. We check about the referenceability of the URI. Here we check for the dead or broken links. That is whether something like when we get a HTTP GET request is sent, we check the status code, whether it's given or 404 not found. This is not supposed to be found when we make such requests. So we also check the usefulness of that data. We check also the changes in the URI in compliance with recommended with respect to recommended implementing redirection using the status code. Then we also check no misreported content types. We detect whether the hypertext transfer response containers header field stating the appropriate content type of the return file, like example application RDF, XML. Then we also check the referenced forward links. Here we talk about the referenceability of all forwarded links, all available triples where the local URI is mentioned in the subject or the description of the resource. For licensing, we check whether there is a machine license. We detect whether there is an indication for a license voiced over the internet description to describe the data set. And we also check whether there is a human readable license. That's a human being that can use that data set based on license provided for any documentation or use or reuse or sharing. We also check whether the dataset contains a particular specified license which is still related to its original content or the original license for that particular dataset. For interlinking, we deal with issue of checking detection of good quality interlinks. We do this detection with respect to detection of interlinking degrees, clustering coefficient, centrality, open SEMAS chains, and description richness through SEMAS by using network measures. And we also do this detection by using crowdsourcing like DPpedia used with respect to Wikipedia. We also talk about existence of links to external data providers. We do a check on the data set whether there is detection of existence and usage of external URI, example, Web Ontology SEMAS links. Then we deal with the reference backlinks. Here we talk about detection of all local in-links or backlinks, all triples from a dataset that have the resources URI as the object. For security context in this accessibility dimension, we are dealing with usage of digital signatures. Here we do it by signing a document containing an RDF serialization, a SPARQL result set, or signing an RDF graph. Authenticity of the data set, we do a verification to check the authenticity of the data set based on a provenance vocabulary such as author and its contributors, the publisher of the data, and its sources if present in the data set. For performance, we check use of /URIs, checking for usage of /URIs where large amount of data is provided. We also check the minimum delay submission of a request by the user and reception of the response from the system, that is respect to low latency. For high throughput, we check maximum number of answered hypertext transfer protocol requests per second. For scalability of a data set, we check data source. We check detection of whether the time to answer an amount of, let's say, 50 requests divided by 50 is not longer than the time it takes to answer one request. Under the intrinsic dimensions, we have 5 subcategories. We have the syntactic validity, we have the semantic validity accuracy, we have consistency, we have conciseness, and also completeness. For syntactic validity, here we are dealing with a dictation. We check the dataset whether there is detecting syntax errors. We do this detection by using validators and also crowdsourcing options. For syntactically accurate values, we do this check by use of explicit definition of the allowed values for a data type. 2. By using also syntactic rules. 3. By using detecting whether the data conforms to the specific RDF pattern and that the types are defined for specific resources. We also check the use of different outlier techniques and clustering for detecting wrong values. For no malformed data type literals, we check detection of ill-typed literals. Instead of typing FOF Jack, type FOF John, which do not abide by the lexical syntax for their respective data type. That can occur if a value is malformed or is a member of incompatible data type. As you can see in the example we have here, a property RDF date of birth for some triples, the range uses XSD date, while for some it uses XSD integer. So we check to make sure that the actual range and value is used. For semantic accuracy, we check for no outliers by using distance-based, deviation-based, and distribution-based methods. And also we use the statistical distribution of a certain type to assess the statement's correctness. We also check no inaccurate values by using functional dependencies between the values of two or more different properties. And also we do comparison between two literal values of a resource, and we also use crowdsourcing. For no inaccurate annotations, labelings, or classifications, we go about with respect to the ratio of inaccurate instances to the total number of instances, and also a balanced distance metric to the ratio of total number of instances. For no misuse of properties, we go by using profiling statistics, which support the detection of discordant values or misused properties and facilitate to find valid format for specific properties. For dictation of valid rules, we check the ratio of number of semantically valid rules to the number of non-trivial rules. An example you can see here we have is spurious annotation, where the object, RDF object Milan in a triple, does not agree with the real world setting, since Milan is not the capital of Italy. But here we have, as we see in the triple, in the ontology we gave as example here, we have Italy, we have Milan being represented as a capital of Italy, which is wrong. Hence, it goes against the semantic accuracy rule for accessing the data set in linked open data cloud system. For consistency, here we check number 1, the number of use of entities as members of disjoint classes. Here we are checking the ratio of number of entities described as members of disjoint classes to the ratio of to the number of total number of entities described in the data set. For no misplaced classes or properties, we are talking about using entailment rules that indicate the position of a term in a triple. For no misuse of web ontology data type property or web ontology data type object property, we deal with detection of these through ontology maintainer. For members of web ontology deprecated class or web ontology deprecated property not used, we detect it by using also ontology maintainer or by specifying manual mappings from deprecated terms to compatible terms. For valid usage of inverse functional properties, we do it by checking the uniqueness and validity of the inverse functional values. And secondly, we also do by defining a SPARQL query as a constraint. For absence of ontology hijacking, dictation of the redefinition by third parties of external classes of properties such that reasoning over data using those external terms is not affected. For no negative dependency/correlation among properties, we use association rules. For no inconsistencies in spatial data, we get this through semantic and geometric constraints. For correct domain and range definition, we deal with attribution of a resource's property with a certain value is only valid if the resource domain, value range, or literal value RDFS ranged is of a certain type detected by use of SPARQL queries as a constraint. No inconsistent values, we deal with this by going to dictation by the generation of a particular set of schema axioms for all properties in a dataset and the manual verification of these axioms. For conciseness, we have high intentional conciseness where we will check the ratio of the number of unique properties/classes of a dataset to the total number of properties and classes in a target schema. For high extensional conciseness, we check number of unique objects of a dataset to the total number of objects representations in the dataset. For usage of unambiguous annotations and labels, we check the ratio of number of ambiguous instances to the ratio of number of instances contained in the semantic metadata set. For completeness, we have schema completeness, which involves the number of classes and properties represented to the ratio of total number of classes and properties. For property completeness, we have the number of values represented for a specific property to the ratio of total number of values for a specific property. We also engage in exploiting statistical distributions of properties and types to characterize the property and then detect completeness. For population completeness, we check it by doing the ratio of number of real-world objects, number of real-world objects that are represented to the ratio of total number of real-world objects. And for linkability completeness, we check the number of instances that are interlinked. That is the ratio of number of instances that are interlinked to the total number of instances in the data set. Under contextual dimensions, we have 4 subcategories. We have relevancy, we have trustworthiness, we have understandability, and we have timeliness. For relevancy, we have number 1, we check relevant terms with meta information. That is information of information attributes. This is done by obtaining relevant data by ranking a numerical value similar to PageRank, which determines the centrality of the RDF documents and statements, and also we use crowdsourcing. For coverage, we are measuring the coverage, that is the number of entities described in a data set, and level of detail, that is the number of properties in a data set, to ensure that the data retrieved is appropriate for the task at hand. For trustworthiness, we have trustworthiness of statements. Here we compute statements. We are talking about computing statement trust values based on number 1, provenance information, which can be either unknown or value in the interval. Number 2, provenance opinion-based method. Number 3, provenance information and trust annotations in semantic web-based social networks. Then annotating triples with provenance data and usage of provenance history to evaluate the trustworthiness of facts. When we talk about trustworthiness through reasoning, we are talking about using annotations for data to encode 2 facets of information. 1, backlisting which indicates that the reference data is known to be harmful. 2. Authority, which indicates a Boolean value, which uses the linked data principle to conservatively determine whether or not information can be trusted. Trustworthiness of statements, datasets, and rules. Here we use trust ontologies that assigns trust values that can be transferred from known to unknown data using number 1, content-based methods from content or rules. Number 2, metadata-based methods based on reputation assignments, user ratings, and provenance rather than the content itself. Trustworthiness of resource. Here we do a computing trust values between two entities through a path by using number 1, a propagation algorithm based on statistical techniques. Number 2, in case there are several paths, trust values from all paths are aggregated based on a weighting mechanism. Trustworthiness of the information provider. Here we compute trustworthiness of the information provider based on number 1, construction of decision networks informed by provenance graphs. 2, checking whether the provider or contributor is contained in a list of trusted providers. 3, indicating the level of trust for the publisher on a scale of 1 to 9. Trustworthiness of information provided, that is the content trust. Here we check content trust based on associations. Example, anything having a relationship to a resource such as author of the dataset that transfers trust from content to resources. Reputation of the dataset. Here we deal with assignment of explicit trust ratings to the dataset by humans or analyzing external links or page ranks. Understandability. Here we check the human readable labeling of classes. We do this by detection of human readable labeling of classes, properties, and entities, as well as indication of metadata. Example, name, description, website of a data set. Indication of one or more exemplary URIs. We detect whether the pattern of the URI is provided in the dataset. Indication of a regular expression that matches the URIs of a dataset. Here we detect whether a regular expression that matches the URIs is present. Indication of an exemplary SPARQL query. Here we detect whether examples of SPARQL queries are provided. Indication of the vocabularies used in the dataset. Here we check whether a list of vocabularies used in the dataset is provided. Provision of message boards and mailing lists. Here we check the effectiveness and efficiency of the usage of the mailing list or the message boards. Timeliness. Here first we check the freshness of the data set based on currency and volatility. Bear in mind that data sets found in linked open data, they are meant to be current and volatile. Current as to say that they are related to the information, real world information. Volatile that they are actually updated as at when due per time. Freshness of data set based on their data source. Here we detect the freshness of the data sets based on their data source by measuring the distance between last modified time of the data source and last modified time of the data set. Representational dimensions of quality of a linked open data is subcategorized into 4. Number 1, representational conciseness, interoperability, interpretability, and versatility. For representational conciseness, number 1, we have to deal with keeping the URIs short. We detect for long URIs or those that contain query parameters that are long. Here we make sure there is no use of prolix RDF features. That is, we detect if there are RDF primitives, that is which are RDF verification, RDF containers, and RDF collection. We check that they are not there. They are not used. Interoperability. Here we deal with reuse of existing terms. So we have to check detection of whether existing terms from all relevant vocabularies for that particular domain have been reused. Reuse of existing vocabularies. We check also the usage of relevant vocabularies for that particular domain. Interpretability of data sets found in linked open data. Here, we deal with the use of self-descriptive formats by identifying objects and terms used to define these objects with globally unique identifiers. 2. Dictating the interpretability of data. This is done by the use of appropriate language, symbols, units, data types, and clear definitions. Invalid usage of undefined classes and properties. Here we engage in detection of invalid usage of undefined classes and properties, that is, those without any formal definition. For no misinterpretation of missing values, we do this by detecting the use of blank nodes. For versatility, we deal with provision of the data in different serialization formats. So we check whether the data has been provided and made available in different serialization formats. We also check whether the data has been made available in different languages for users or machines. Some of the problems that are associated with linked open data. 1 is the intent of data providers. We have come to know that linked data refers to a web-scale knowledge base consisting of interlinked published data from a multitude of autonomous information providers. So they are autonomous, so they can provide any type of information, whether it's good or not okay, whether it's complete or not okay. So in such a case where they provide incomplete data, there is a problem that data found in linked open data are not of good quality. Increased usage of linked open data. Because of the amount of availability of this linked open data, there are so many people using it. So there are so many data also available. So it makes it difficult for people to access a qualitative data because of this diffusion rate of linked open data available to people. Then we have misappropriation of data sets by original creators. Actually, it's not the original creator that misappropriates, it's actually the third-party applications or human being that misappropriate such data. We also have difficulty in modeling because linked data provides data integration through interlinking data between heterogeneous data sources. Then we find out that data relationship here is not straightforward, so you cannot use it for modeling most times. It's very difficult. Dynamic updating, because the fact that linked open data is current, it needs to be current and volatile. Most time, the information found in data set contained in linked open data, they do not represent the actual change in the real world environment. So it makes it also difficult for data set found in linked open data to be of good quality. Some relationship between relational database system and linked open data is that we can find that it deals with structured data sets. It involves large heterogeneous and distributed data sets. Both of them deal with closed word assumption. Both of them deal with open word assumption. Both of them deal with representational dimensions. Some of the benefits of open data is that they are transparent. They enable users to develop applications at their own pace and dynamism. It improves data description explicitly. It encourages data integration. It authorizes semantic collaboration. It makes for easy navigation of complex data. It brings easy updating where available. It encourages decreased cost of data reusability. It encourages complementarity. It encourages data reusability. It also brings about data sharing on the web very easily. It promotes collaboration of citizens with the government, with institutions, with schools that makes their data available on this cloud system. Literature review how that Teaching C and RAS 2019 their work gave information that there is need for qualitative data to be found in linked open data so that professionals who use them can make good decisions. Whereby also they stated also that if there is no qualitative data in this linked open data system, there is going to be bound to be disaster for researchers, for business personnel, for scientists, for workers. Hence, there is need for improvement on the best quality of data set to be found in linked open data system on the cloud. In conclusion, this work was done as a group work. We were able to do definition of quality data, measurement attributes for assessing quality of data sets in linked open data cloud. We also did some relationship between normal relational database and linked open data. We also presented some issues and problems found in data set found contain linked open data. These findings were done with some academic literature reviews that we could lay our hands on. And though this work contains a review of some academic research in this field, we feel the test for just the purpose of giving a basic idea to listeners or audience about the metrics or attributes used in assessing qualitative data set contained in linked open data. More studies can be done to get detailed insight of how quality of data sets in linked open data can be assessed or reviewed in order to improve reliability, relevancy, consistency, completeness, validity, and conciseness of data sets for use, reuse, and sharing across the web in a generation where we are already based, our life is completely based on data sets and data usage. Thanks for your time. These are references, some of our references. God bless.